This is the lesson for 3B-4 input-output notes. Remember, you can find constant rate of change slope from your table. You also can find it from the equation. From the equation, it's 3/2. You also can find your y-intercept, which is your -2. I'll remember that my 0 or y-intercept term is 0 and a number. So the nice thing is I know that 0, 2 is my, -2. -2 is my y-intercept. My rate of change, or m, is my slope. So I know from here it's 3/2. I know my 0 term is -2. I know because there's an add and a subtract, it is not proportional. I also know the y-intercept is the same as my 0 term, so that is -2. Where do I see it on the graph? I see it the point where line crosses y-axis. Where do I see it in the table? 0, number. So I'm going to do some math to fill in my function table. So I am going to start with the 0 term, because that's the nicest math. And I say 3/2. I replace my x with a 0, -2. 3/2 times 0 is 0, -2 is -2. Okay? Then I'm going to do 3/2 times 2 over 1 minus 2. These cross out. So 3 over 1 is 3, minus 2 is 1. So that's 2, 1. And then I'm going to go 3 times 4 over 1. 3/2 times 4 over 1. That's 3 times 4 is 12. 12 divided by 2 is 6. 6 minus 2 is 4. And so that is 4 and 4. That looks like a Y. 4. And then I am going to do my negatives. I do my negatives last because I don't want to mess up my signs. 3/2 times -2, -2 over 1. So I'm going to put a little 1 there. Numerator is -6 divided by 2. -6 divided by 2 is -3. Oh, but I have to subtract 2, and that's -5. And then nope. 3/2 times -4 minus 2. Doing this part is -12. Divided by 2 is -6, minus 2 is -8. So if you notice, what I was doing is I was putting my value here, and I was inputting my x value, replacing my x with my value. And let me finish, go ahead and finish, and this is -2, -5, and this is -4, -8. Because this is my x value, which is coming from this column, and my y value is coming from this column. Now, there's magic that happens in the table. Remember yesterday when we were calculating slope from a table, and I did my little change of y over change of x, plus 3, plus 3, plus 3, plus 3. That shows up right here. And then here is plus 2, plus 2, plus 2, plus 2. Okay? So there is my slope is y, change of y over the change of x, and I calculated as 3 over 2 from the table, and it showed up there. You're going to see things show up a lot. So I can go and plot every single one of these points, just like you were doing on Bellwork. There's a faster way to plot this entire graph. Remember, I said the y-intercept is where it crosses the y-axis. So I'm going to plot my 3 and my -2, which was my y-intercept. Remember yesterday when we had a line, we counted up and then we counted over, correct? Well, we don't have a line, but we can still count up and count over. So my slope is 3, 2. And I asked you yesterday, is that a positive slope or a negative slope? And you said it was a positive slope. And when we said it was a positive slope, we called it rise over run. So I'm going to count up 3, 1, 2, 3, and then count over 2 and put a dot. And then I'm going to do it again. 1, 2, 3, 1, 2, and put a dot. And I'm going to go 1, 2, 3, 1, 2, and put a dot. Well, if I'm going 3 up and 2 right, and I've got to connect my line, I'm then going to go 3 down and 2 left. So I'm going to go back to my y-intercept and go 3 down, 2, 3, 2 left. Notice he's lining up. And then I can take my line and I can connect my line. If you didn't want to do it by slope and y-intercept, I could plot every single one of the solution set and it's the same thing. So it doesn't look crowded. I'm going to erase my how I calculated slope. And there's problem 1. It's pretty much the same thing over and over. Okay? So I'm going to look at my equation and I'm going to decide that my equation is y equals 1x minus 1. Because when there's not a number in front of the x, it is an implied 1. The next thing I'm going to notice is that my y-intercept is -1. Y-intercept equals -1, which means that this number right here is -1. Okay? So it's 0, -1. No math involved. I'm going to do the math to it now. 0 minus 1 equals -1. Now I'm going to replace my x with a 2 minus 1, which is 1. And then 3 minus 1, which is 2. And I'm going to go, that looks like a pretty neat pattern. And I'm going to say, when it's 2, it's 1. And when it's 3, it's 2. And then I'm going to say -1 minus 1. It's -2. So 0 minus 2. And -2 minus 1 is -3. So I'm going to put a -3 here. So -2, -3. Now, from here to here is +2, and here to here is +2. So that's 2 over 2 equals 1. From here to here, it's +1, and from here to here is +1, and 1 over 1 equals 1. So every time I calculate slope, it's going to be the same thing. So again, I'm going to plot my y-intercept at -1 on the y-axis. My slope is 1. It's positive, so that means it's rise over run. I also know that I have to do this as a fraction, and 1 over 1 is the equivalent fraction to 1. So that means I'm going to go 1 up and 1 right and put a dot. 1 up, 1 right, put a dot. 1 up, 1 right, put a dot. And what I'm doing is I'm doing this, going 1 up, 1 right. 1 up, 1 right. 1 up, 1 right. If you notice that it's going through the diagonals of the little boxes. I'm going to put little arrowheads because it's a line. Rate of change. Well, I could see it from the table when I did my change of y over change of x. I could also see it from the equation that it's 1. And my 0 term, or my y-intercept, or my b, is -1. Is it proportional? No, because there is adding and subtracting on my equation. Here we go. My point, my y-intercept is 2, so 0, 2. Now, I'm going to work backwards on this one, and you can, or you don't have to. This says -2 over 3. That says that's my change of y, and that's my change of x. So if I'm going to subtract 2, I end up at 0. And if I subtract 2 again, I end up at -2. Well, my change of y is add 3, 3, add 3, 6. Now I'm doing this before I do the math, because if I don't like to do the math, I'm going to do it by reading the change of y over the change of x. Now if I subtract 2 to go down my table, I have to add 2 to go up to my table. So that would be a 4, and that would be a 6. And we're going to see if this works when I do the math. And that would be and if I add 3 to go down the table, I got to subtract 3 and subtract 3. Now let's see if this works. Let's see if the math works. And I will tell you it does work. So I do -2 thirds times 0 plus 2. Anything times that, anything times 0 is 0. So I just have a 2. That one checks out. -2 thirds times 3 plus 2. A negative times a negative is a positive. That scratches out. -2 plus 2 is 0, so that works. -2 thirds times 6 plus 2 is negative 12 over 3, which is negative 4. Negative 4 plus 2 is negative 2. That works out. Negative 2/3 times negative 3. A negative times a negative is a positive. It would be 6 over 3, which is 2. 2 plus 2, which is 4. And that works out. And then negative 2/3 times 6, negative 6, is positive 12 over 3, which is 4. 4 plus 2, which is 6. Okay? If I was graphing this, I would first put my dot at positive 2 on the y-axis, because that is my y-intercept right there. Then I would notice that my slope is negative 2/3. And remember yesterday when we were talking about calculating graph or looking at slope on the graph, we said a negative was a fall and a run. So I'm going to go down 2, 1, 2, and then run 1, 2, 3, and put a dot. And then I'm going to go down 2, 1, 2, 3, and put a dot. Well, if I go 2 down and 3 right, those are the movements of slope, then I must go 2 up, 3 left. So if I go 2 up, 1, 2, 3, 2 up, 1, 2, 3. And then if I connect my line, put arrowheads because it is a line, and erase my how I got there, it works. My rate of change, or M, is negative 2/3. I did that from my equation. So right there, the number attached to the x. My zero term, or b, or my slope intercept is 2. Is the function equation proportional or not? And no, because it would have to be y equals negative 2/3 x with no adding and subtracting. That is proportional. But once you put in a plus 2 or minus 2, it is no longer proportional. Your job is going to be able to be responsible for creating a function table and then plotting it.